Hello everyone, today we are going to learn about Elgamel Encryption. Elgamal crypto system uses asymmetric encryption. Here, we are going to illustrate this crypto system with an example. It's needed to transfer a message securely to Bob. Therefore, a key is required to transmit the message securely to Bob. The main difference between symmetric and asymmetric is that symmetric uses the same key to decrypt the message, while asymmetric uses a different key to decrypt the message. Elgamal was first described by Elgamal in 1985. He came out with this encryption system as part of his PhD thesis. Elgamal crypto system is based on Diffie-Hellman key exchange. Diffie-Hellman key exchange is a specific method of securely exchanging cryptographic keys over a public channel, and its security depends on the difficulty of solving discrete logarithm problem. So, how do two people who never met are able to agree on a secret share key? Now, we'll use Alice and Bob for example again. Firstly, Alice needs to decide a public key, which is yellow, and send it to Bob. Now, Alice and Bob both knows yellow as their public key. Next, Alice and Bob randomly select a private color and mix them with the public color, which is yellow. The new color, orange and green, are being exchanged between Alice and Bob. After that, Alice will add her private color red to the mixture obtained from Bob, which is green, to obtain the shared secret key, while on the other side, Bob will mix his private color blue and the obtained mixture from Alice, which is orange, to obtain the same shared secret key. The shared secret key is used for the encryption and decryption of a message. This is how two people who never met are able to agree on a shared secret key. Jing 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 jing! Here we come, the bad guy appeared. The bad guy are able to intercept any data that are being transmitted. We notice that the bad guy are not able to obtain the private key, which is red and blue color. While he is not able to obtain the private key, he is not able to deduce the secret key as well. Therefore, we can conclude that the bad guy are not able to decrypt the message even if he has successfully intercepted the message. In this example, we notice that it's easy to mix two colors together to make a third color, while it's hard to reverse a mixed color to find the original exact color. This is known as one-way function. However, in real-life scenarios, instead of colors, it is replaced with complicated mathematical formulas. Now, for the Elgamal encryption, we'll explain the process with a simple example. Let's say Bob wanted to send a message to Alice. However, to do that, Alice has to create and publish her public key for Bob. To create a public key, three ingredients are needed: a random prime number P, a random secret key A, and a generator G, which is a primitive root of modulus P. Alice's private key will be used as exponent for the generator G and are computed together with the chosen prime cyclic group P. The computed result H, or we could call it Alice's contribution, is then added as part of public key, along with the generator and prime number G and P. Now, for the encryption part, Bob will generate his own secret key B after he receives Alice's public key. By using his private key as exponent for Alice's contribution, H to the power of B, Bob will obtain the secret shared key between Alice. With the secret key at hand, Bob then is able to encrypt his message. Before sending the ciphertext, to ensure Alice and only Alice is able to decrypt the message, Bob will compute his contribution U based on the same algorithm used by Alice. By attaching his contribution to the ciphertext as header, he then sends the encrypted message to Alice. If you notice, Alice's contribution H is derived from G to the power of A, and so H to the power of B is actually equivalent to G to the power of AB. Since Bob's contribution U is equal to G to the power of AB, by using her secret key as exponent for the Bob contribution, Alice is able to decrypt the ciphertext. Thank you for watching our video. We hope to see you again next time.